So we have about 15 minutes of class. We went over our test. We did checkpoint. So let's look at some example problems. Yesterday we just tried converting between sine and cosine and tangent, so that we wrote everything in terms of sine and cosine and saw things cancel. So let's look at problem L. What's different about L compared to the others? What's different about this compared to yesterday? Yeah, I got some parentheses. We have a cosine squared. We didn't really have many squares yesterday. And if you look throughout this problem here, there's actually a lot of squares, aren't there? Well, sometimes we can insert something to take the place of something else. Now, you will become frustrated. And the reason why is because you will want to know the set procedure each time for solving these. There is not a set procedure. It's kind of like this. If I ask you, what are the factors of 15? What are they? 5 and 3. Now, if somebody didn't know the factors of 15 and they said, Cass, how did you figure out the factors of 15? What would you tell them? You just memorized them. You learned them over time, right? You would say, well, I look for what divided into 15. They're like, well, what? I don't know the division piece. They're like, well, I guess it's just something I learned and practiced. That's what we're doing right now. You're trying to become familiar enough with these things so that you recognize them. Okay? Right here, I don't like this 1 minus cosine squared. I could multiply through by a cosecant, but it would make things kind of messy. Instead, I'm going to insert something for 1 minus cosine squared. Please look at the sheet that I gave you. I have compiled, along with these four, today, and for the rest of the time, we're going to be looking at 5, 6, and 7 as well. And there's a very important formula right here. Have you learned that sine squared plus cosine squared is 1? Yes. Watch what I can do with this formula. If I subtract a cosine squared of x from both sides, I end up with a new formula. What is it? Sine squared of x is equal to 1 minus cosine squared of x. And if you look, I've actually written these down for you over there as well. These boxes show all the different ways that these three can be written. Not all of them. We'll make a few twists and turns on our own, but these are some of them, okay? So what I'm going to do is I'm going to use that fact to simplify this expression. Instead of writing a 1 minus cosine squared, what can I write in its place? Sine squared of theta times cosecant of theta. Now I have an expression that was very similar to yesterday, correct? So I will now write it in terms of sine and cosine. Sine squared of theta over 1 times, how do I rewrite cosecant? Yep, for those who weren't here yesterday, if you look, it says cosecant is 1 over sine. So therefore, I could choose to insert that piece. 1 over sine of theta. So, do both the sines cancel or just one? One of them cancel, okay? So this gets reduced to 1, and that cancels, leaving you with sine of theta. So who would have thunk that 1 minus cosine squared times cosecant ends up being sine? But it does. Okay. Again, look at m. Cosine squared times secant squared minus 1. I could distribute that through, but I'm going to choose not to. I am going to look at what secant squared minus 1 might be. Anytime I have a squared and a 1, there's a good possibility that it matches up with something else. You see something up here that involves a secant squared and a minus 1. Where? Yep, right here. So I have secant squared minus 1 is tangent squared. Don't choose this very bottom one. That won't help us right now. We'd like to choose the easier one, which is to write it as tangent squared. Okay? When I saw the 1 and the secant squared, my eyes were drawn to number 6. I went over here and I saw that it is in fact equal to tangent squared. So I will go ahead and take this And I will write cosine squared of theta times what? Tangent squared. Now, this looks like something that we had yesterday, right? How do you rewrite cosine squared? Just cosine squared. We don't want to change it. How do you rewrite tangent squared? Sine squared of theta over cosine squared of theta. Very good. What am I left with? Sine squared of theta. Again, n, secant squared of theta minus 1. I could try to divide each by sine squared, but there's probably a better way. What can I insert for secant squared minus 1? Exactly what we did in the previous problem. We can insert tangent squared. Again, this looks like what we had yesterday, doesn't it? Question. Secant squared minus 1. Secant squared minus 1 is tangent squared. If I took this and simply subtracted a 1 from both sides, I would get tangent squared of x is equal to secant squared of x minus 1. So I have that formula that I can use. So I can place that for that. Does that make sense? Okay. So let's go to that problem. Tangent squared I can rewrite as sine squared of theta over cosine squared of theta over sine squared of theta over 1. How do I divide the fractions? What happens? Sine squareds cancel, leaving you with, hey, that looks a lot better than it did at the beginning, but I know that 1 over cosine is equal to something. Secant. So 1 over cosine squared is secant squared. What do you think? Notice how we're building off of yesterday. We're just adding that one more step in. We're looking at the squareds. We just want to do 3 more examples. And you have yesterday you had a short assignment, didn't you? It was 8 problems that were just very short, like we did in our checkpoint. So today you're going to have a short assignment again, but you need to keep up with it. Otherwise, you'll come back to it and be very confused. Okay, I see that these have a tangent squared in both terms. And sometimes, if you look here, the cosecant is factored out. The cosine squared is factored out. Watch what I do, folks, okay? You could write this as cosine squared of theta times secant squared of theta. And then distribute that there to get minus cosine squared of theta. But that would make it more difficult, wouldn't it? Okay? We like it in the factored form better, don't we? Well, look at O. O is in the unfactored form. So what do these both have in common that we can take out? A tangent squared. For example, if this was x squared minus x squared y squared, what do both of those have? An x squared. If I took out an x squared, what is left in place of this x squared? A 1 minus what's left here? A y squared. Good. So if we take a tangent squared out of this, what are you left with? 1 minus, what are you left with here? Sine squared. Okay, I factored it out, and now I can see I have a 1 minus sine squared. If we have a 1 and a squared, there's a good chance we can plug something in. What on your sheet does it say you can plug in for 1 minus sine squared? cosine squared right here. 1 minus sine squared is cosine squared. So tangent squared times cosine squared. Hey, that looks like a problem that we did yesterday. Let's rewrite this in terms of sine and cosine. Sine squared over cosine squared times cosine squared over 1. What happens? I'm laughing because Dylan Jansen just asked me to prompt. So, yeah, it was awkward, but it was also fun. Okay. Okay, what can I what can I factor out of the next one? What can I factor out of this one? Sine squared. When you factor a sine squared out of the first part, what are you left with? Secant squared. Minus, when you factor sine squared out of this, you're left with 1. Hey, secant squared minus 1, that looks familiar to me. What is secant squared minus 1? So I have sine squared of theta times tangent squared of theta. Now, when I multiply these, let's change tangent squared. Sine squared over 1 times, instead of tangent squared, what do I write? Sine squared over cosine squared. Does anything cancel? No, you would get sine to what power? Sine to the 4th. That's not any more simplified, is it? So the truth is, it doesn't get any more simplified than that. Sometimes you find that out as you try to work through the problem, that something doesn't cancel sometimes. Okay, we'll get to those later. No, we'll get to them on Thursday. Tomorrow we'll be doing a review practice day together so we can get these really well. We'll be playing a game. Okay, Q, what can you take out of both? A cosine squared. Good. When I take out a cosine squared, what are you left with here? 1 plus. Did we have a question why the 1 is left there? If you take cosine squared times 1, what do you get? Cosine squared. If you didn't put the 1 there, how would you come up with the cosine squared? Cosine squared. Okay, so as you distribute, cosine squared times 1 is cosine squared. Cosine squared times tangent squared is cosine squared tangent squared. If you didn't put that 1 there, how would you come back up with that cosine squared? You wouldn't. So it has to be there. What can I plug in for whoop? Oh man. Yep. Sometimes you do really difficult math, the smartboard breaks. Okay, what can I put in place of the 1 plus the tangent squared? Secant squared. So write cosine squared times secant squared. Hey, maybe those will simplify. Cosine squared over 1 times, how do you rewrite? 1 over cosine squared. And I get 1. Sometimes you get a nice number like that. Okay, so you see just a couple examples. Today we're going to practice with the substituting for squareds. Okay, well, Okay, so I had 8 problems for you yesterday. Today you have 1, 2, 3, 4, 5, 6, and then plus 4 more, so 10. So 10 just like we did, and I want you to know tomorrow you're not going to get a new assignment. But that doesn't mean to put this off until Thursday or Friday. Practice it while it's fresh, and you'll have a better chance of remembering it for the future, okay? So there's your assignment. I'm sure you'll do a great job. We'll practice tomorrow again.